Hello, and welcome to Bay Area Modern Web. My name is Eva, and I am Operations Manager at this.labs. Tonight, this is Modern Web. It is also sponsored by the GDGs, Google Developer Groups. This.labs is our sponsor, as I say. This.labs is the place that I work. It's a tech consultancy. We do all things open source, specializing in open source frameworks and helping people do digital transformations and all that good stuff. So if you need help, please give us a holler. You can send us an email at hi@this.co. We have two awesome speakers tonight that I'm super excited about. Sam is going to be chatting tonight about the role of effects in NgRx authentication, and Vincenzo is going to be talking about when an error is not an exception. I have a couple of announcements. I have a couple of announcements for tonight. We have some upcoming events that you all might be interested in. The next one is actually going to be tomorrow at 12:30 Pacific time. It's going to be the Global Angular Meetup, and it's going to be on the state of NgRx, which should be really interesting. And then we have a GraphQL fireside chat on May 12th at 9 a.m. Pacific on event-driven applications with GraphQL and serverless. Then we have a React Meetup on May 14th at 12:30 Pacific. And on May 21st at 12:30 Pacific, we have our Vue Meetup. Losing my ability to talk. Anyway, this little schedule, Sam is going to actually be first, and then he's going to do his talk, and then we'll answer a couple of questions. We'd love to have input from the audience. If you've got a burning question for Sam, please feel free to type it in the comments, and he will either answer questions during his chat or afterwards, depending on how he feels. And then we're going to do a little JavaScript Jeopardy interspersed with some very fun dad jokes. And then Vincenzo is going to do his chat, and then we'll have some closing notes and goodbye. So with that, I will hand it over to Sam.
Hey, everyone. Glad to be here. Let's see, share my screen here. And head over to Keynote. All right, we good? I'm assuming that's a yes. Can you hear me? Can you see my screen? I'm going to take that as a yes. Okay, so we are going to talk today about the role of effects in NgRx authentication. So I am a big fan of NgRx. I love NgRx. I love teaching NgRx. I really just love breaking down really complex and abstract concepts of the Redux pattern and trying to make it understandable especially to newcomers and junior developers. And one thing that I've been finding as I've been teaching NgRx and talking to people about NgRx and learning it myself, honestly, is that effects tend to be one of the hardest parts of learning NgRx. So one thing that I think is that effects, even though effects are really powerful and can do a lot of things, they tend to be a lot more abstract than actions and reducers. So that makes it a little bit complicated as we're getting to know NgRx for things like authentication, because it turns out that effects are also a huge part of implementing auth in NgRx. So if you think about that and you put those two together, on the one hand, effects are one of the most complicated parts of learning NgRx, and they're also a huge part of authentication in NgRx. It doesn't take, a rocket scientist to do that math. And so that can lead people to feeling a little overwhelmed once they start implementing auth in their NgRx app. So the goal of this talk is to help you go from this reaction to more of this reaction. So from panic to a sigh of relief. So what we're going to talk about today is the role of effects in NgRx. And you're going to hear this phrase come up: effects are the DJ of NgRx. So we're going to talk about what that means, what effects actually do. And then we're going to talk about common struggles people tend to have with the login flow and how you can overcome those struggles. Finally, we'll talk about the login flow specifically. So after we cover just the general struggles with effects, then we'll talk about effects in the actual login flow. So I'm Sam Julien. I am a senior developer advocate engineer at Auth0. I'm also an Angular GDE and a collaborator. And then I love to teach online. So I built a course on NgUpgrade called upgradingangularjs.com. And I'm also an instructor for both Thinkster and Egghead. I do a lot of content on both Angular and React. Okay, so let's talk about the role of effects in NgRx. And I like to say that effects are the DJ of NgRx. But in order to do that, let's take a quick step back and have a quick architecture review. So in vanilla Angular, we tend to have our services and our components, and they're talking to each other directly. The services and components talk to each other, and there's kind of a two-way communication there. NgRx doesn't really work this way. Instead of having this services and components two-way communication, we have this architecture that's a little bit more complicated. So we have application state, which is dispatched by actions to reducers, and then our components read that state through selectors. Effects can also listen for actions and handle side effects. So let's talk a little bit more about effects. So effects do a few different things. They decide when to call the services, they communicate with APIs, and they handle control flow logic. So these first two, I think, are where people tend to get effects. They start to think like, oh, okay, I need to call an API, and so I'm going to use an effect for that. But I think this third one of handling control flow logic is a little bit of a deeper dive when you start learning NgRx. So what do I mean by effects handling control flow logic? Well, you can think of effects as a task runner. So I like to say that effects are the brain of NgRx. Mike and Brandon say that effects are the meat of the NgRx lasagna. Personally, I like to say that they're the DJ of the NgRx dance floor. They make sure that everybody is having a good time and that the music is playing in the right order. But everything's not a bowl of cherries when it comes to effects. People tend to have a few different struggles when it comes with effects. So let's look at those. There's three major things about effects that people tend to get tripped up with when they're learning them. First, they tend to struggle with actions that only trigger effects. So for example, these are actions that don't touch the reducer at all to modify state. I think it's easy to remember when, so you call an API, for example, you get data back, and then you dispatch a new action. That pattern is sort of easy to digest. But then sometimes you have these actions that don't trigger any effects. Same thing happens with non-dispatching effects. So for example, these are effects that don't return an action. And we're going to see that in just a little bit. The last thing that people tend to get messed up with effects is writing complex effects. So this is when you try to handle multiple side effects at once. And we're going to see an example of this a little bit later. So let's talk about NgRx plus authentication. And if we look at effects in NgRx authentication, we can kind of go through this list. Do we have actions that only trigger effects? Yes, we actually do. Do we have non-dispatching effects? Yes, we do. And do we have complex effects when we're implementing auth in NgRx? Yes, we do. So Let's look at the role of effects in NgRx in the login flow. Before we do that, though, we kind of need to take a step back. I keep referring to like auth or the login flow, but I haven't really talked about what I actually mean by that. So let's look at a diagram of that. So we're going to kick off the login process, usually using like a button or maybe when the app first starts. And then we're going to be sent off to our provider. So some sort of identity provider that's going to be checking the user's credentials and then sending back a token with basically sending us back to our application. Once they send us back to our application, then we need to work with some sort of SDK that the provider will have for Angular. And we need to process that redirect. Usually that redirect, the SDK is going to go do some work, and it's going to bring us back either a success or an error message. Inside of that success is typically where we get things like the user and the token. And then we also will send the user off to some other page, or maybe the page that they were at when they logged in. So when we go to do this in Angular, when we go to write this code in Angular to log our user in, we usually start with a big auth service, usually kind of a big class that is doing a lot of things. It does things like store the token in the user in memory, it interacts with the auth SDK, and it handles that redirect logic of sending the user off somewhere else. And then that auth service interacts directly with the components. You inject that auth service into the component, and you use it for things like getting the token, things like that. You might also have that auth service interact with data services. So for example, if you need to add that token to your outgoing requests so that you can hit a protected API. So NgRx authentication, this login flow looks really different in NgRx, and that can be really confusing at first. So for example, instead of having this flow of the service with the data service and the components, we move to this more indirect flow of architecture that we mentioned earlier. So the auth service goes from this thick service with a lot of responsibility to actually more of a thin layer alongside of our effects. And then the rest of those responsibilities get spread between the effects, the reducers, and the selectors. Okay, so now let's put all these together. And let's look at the flow of logging in again, but this time let's keep NgRx in mind. So I have a challenge though, as we look at this one more time. Which parts of the auth flow directly change state? This is sort of the key of understanding how auth works in NgRx. So again, we kick off the login process by clicking a login button usually. Then we get sent over to our provider, and then we get sent back, and we have to handle that redirect. And then we have to work with the SDK in order to get back a success or an error. And then we process that success, and we get our user and our token, and we send the user off to wherever they're going. Okay, did you think about, as we were going through that, where does state actually change in that entire flow? It actually only changes in one spot, which is getting the user and the token. Out of that entire process, we're just getting a user and a token. And these are the two things that we're going to keep in our store, in our state. Everything else in that entire process is a side effect, which means that everything else in that process needs effects. So that's why understanding effects is so key to this entire process. Okay, so if we go back and we think about this again with our login flow, let's start with this. Let's zoom into this first half of starting the login and logging into the provider. If we were to implement this in NgRx, first thing we would do is we would start with an action. So we would create this action called login and namespace it under auth and call and just emit start login basically. And then we'd want to create an effect for this. So we have this login effect. We create the effect with the new, this is, by the way, I should mention I'm using the NgRx 8 creator functions that came out. So if you're using NgRx 7 or below, some of this might look a little weird to you, but these utility functions of create effect and create reducer and create action are really, really nice. Save you a lot of boilerplate. So we're going to listen for that login auth action that we created. And then we're going to use the tap operator to call the login function on the auth service. So what is this login function on the auth service? Let's zoom in on that and check that out. So the auth service here is going to have this login function, and notice that it's really just a pass-through call to the auth client. The auth client is the SDK that we're using, and we're just going to call the login with redirect function that's on that SDK. So that's what I meant when I said that the authentication service is just this thin layer that lies alongside of the effects. All of our calls here are just basically going to be pass-throughs called by our effect. Okay, so we're back to our login effect here, and we have this tap operator where we call the login function on our auth service, and then we need to call this dispatch false. So this is an options object that you can pass into an effect. And so this is the example of an effect that doesn't dispatch an action. Notice here that we didn't actually return any sort of new action. So we've come across our first struggle with NgRx, an action that only triggers an effect, and our second one of a non-dispatching effect. And the way that we can work through this is we need to remember that effects function as a task runner. Remember I said that effects are the DJ of the NgRx dance floor, but I didn't really explain what that meant. I just sort of mentioned that they keep the show running. Let's think about this. If you say, hey DJ, play my favorite song, nothing actually happens instantly until your DJ nothing would happen instantly unless your DJ just sort of like stopped everything and started serenading you on the spot. So the DJ actually has to do a few things to make that song play, right? They have to grab the record and put it on the player and then play the song. And then, the song starts playing. And the song is sort of like our state, the song playing. Whereas these other two things were basically side effects that had to happen in order for that song state to change. Does that make sense? So we can instead of thinking of the logging in, or instead of playing your favorite song, you can think of you're saying to the app, hey app, log me in. And a few different things have to happen, right? You have to call the auth service to log in. You got to handle the redirect flow. And then you've got to update the store with the user and the token and anything else that you want to store. And so if we think of that same model, these first two are really just tasks that need to be run in order to update the state of our application. So that's the first two. We've got those covered. Let's look at the second half of this process where we're handling the redirect and then we're processing the success with the user and token and then sending the user off to their next thing, to the next route. So we would probably create a handle redirect action. And then once we've done that, we would create a handle redirect effect. So this handle redirect effect would be listening for that handle redirect action. And we'd probably do some sort of exhaust map or concat map here. But what would we put inside of it? Let's zoom in on that. Okay, so this is where things start to get a little bit confusing because we know that we need to call the handle redirect function on the SDK. This is basically just that function that the SDK will use to go get the token and the user and whatever else, or just return that to us. But then what do we do after that? Do we set the user and token somewhere? Do we navigate to the redirect URL? Do we dispatch an action? That's where things start to get a little complex. We also know that we need to do some sort of error handling here, so we can include that. But again, we're pretty unclear as to what goes here. It seems like this isn't the spot that we would set the user and the token. It also seems like navigating to the redirect URL would prevent us from returning a new action. So this is where things get a little complicated. So let's unwind this. Well, what we've come across is a complex effect. This is when you're trying to do too much at once. Usually I find that I've missed something or I've taken something for granted here when I find myself really confused about how to structure an effect. I find that the first thing I need to do is back up and try to play a little game called Find the Hidden Side Effect. Usually I've missed something. So if we go back and look at handling the redirect and working with the SDK and then processing the user and the token and doing the redirect, you can see that we're missing something here. We're trying to do too much at once. So what really helps is to break the complex effect into smaller pieces and make sure that you're letting one effect handle one side effect. When I was building out this talk, I went over everything with Mike Ryan, and he said that if he were to ever give a talk on good effect hygiene, this would definitely be one of the tenets. Let one effect handle one side effect. Okay, so let's do what we did before and write out the steps like we did for the initial login. And that'll help us clarify what's actually a side effect and what is changing state. So first we need to call the auth service to process everything. Then we need to update the store with our user and token. And then we need to redirect the user. So if we stop and we think about this for a second of what in here is a side effect and what is changing state, the only thing that's changing state is updating the store, right? And then these other two things are side effects. So if we go back to our confused effort of our handle redirect effect here, what we've missed is that this is actually a side effect already. We're already creating a side effect by calling the handle redirect function on the auth service. So that's already one side effect. And so instead of doing all of this in addition to that, in addition to that one side effect, we're going to keep good action hygiene and we're going to break this into two different effects. So we're going to refactor this to where we dispatch a new action of handle redirect success. And we're going to include in that, the payload of that is going to be the payload from the token or from the SDK, which will be like the token and the user. And it will also be the redirect URL. Usually your SDK will provide that for you, or you might have stored your redirect URL in local storage. But either way you get it, you're going to pass it along with handle redirect success. So now we can go back to the reducer and create a new case for handling that and updating our store. So when we dispatch handle redirect success with our payload, we're going to update our token and our user in the store in this in our reducer, basically. Okay, and so then once we've done that, we're going to create a new effect to go alongside of that handle redirect success action. So we'll have this effect of handle redirect success, which listens for that new action that we created. And then we'll call our tap operator again and navigate the user to the redirect URL. So we've broken this apart into two different actions and two different effects. And now we're not doing too many things at once. Now, again, since we're not returning a new action here, we need to set that dispatch option to false in our create effect function here. Okay, so now we've seen all three. We've seen actions that only trigger effects. We've seen non-dispatching actions, and we have learned about writing complex effects. So I know I've hit you with a ton of information. Let's just do a quick review here. So I mentioned in the beginning that effects are one of the hardest parts of learning NgRx. At the same time, coincidentally, they're also a huge part of implementing authentication in NgRx. In vanilla Angular, we tend to have this pattern of having a really big authentication service that interacts with our components and data services. But in NgRx, we have this different architecture, right? We have this architecture where our state is being modified in the reducers, and our components are using selectors to read that state. And then our auth service and our effects are working together for receiving actions, dispatching actions, and triggering those updates in the store. So then we talked about the role of effects. What do effects do in NgRx? Can you remember? They decide when to call services. They communicate with our APIs, and they handle control flow logic, which means they're effectively a task runner. And like I said, most people, when they learn about effects, they tend to associate effects with calling APIs. And so that third one of handling control flow logic kind of gets swept under the rug. But it's important to remember that effects are like the DJ of the NgRx dance floor. They're running the show, basically. We also talked about the three effects, or the three struggles that people have with effects: actions that only trigger effects, non-dispatching actions, and then complex effects. And then it turns out that NgRx authentication also has all three of these things. So we looked at the first half of the login flow and found out that we already have actions that only trigger effects and non-dispatching effects. And in order to help us understand that a little bit better and overcome those struggles, we needed to remember that effects function as a task runner. So we looked at the example of the DJ and translated that to our app and figured out that calling the auth service and handling the redirect flow are both side effects, and only updating the store affects our state. And then we looked at the second half where we process the token and redirect the user. And that's where we encountered our complex effects. And we talked about how when you encounter a complex effect, it's sort of like a code smell where if you feel like something is wrong, something probably is. And you need to usually back up and try to find that hidden side effect. Break the complex effect into smaller pieces. Go back over things so that you can let one effect handle one side effect. We looked at our example where we listed everything out that needed to happen, and again, tried to identify what are the side effects and what are the store. I know that kind of seems like an elementary exercise to do, but it honestly really helps. Like if you're trying to keep straight, like, where am I actually changing data here, and what is actually just sort of a task that's being run? It actually legitimately helps when you do that. And we figured out that updating the store, again, was the only thing that's actually changing state. So we looked at all three of these struggles and we checked them off one by one. And so hopefully after this talk, you're feeling a lot less overwhelmed about NgRx authentication, and you can breathe a little bit of a sigh of relief. So lastly, before I go, I hopefully in November, we're going to be able to do NgRx Conf if all things go okay. And I do have a discount code for that ticket. Of course, they do have a contingency plan if we end up having to call that off, but it should be a great conference if it happens. You can find these slides at samj.im/ngconfhardwired. That's where I first gave this talk. And always feel free to reach out to me on Twitter. I mean, part of my job as a GDE and as a developer advocate for Auth0 is to answer questions that you might have about auth in Angular or auth in NgRx, or really just anything having to do with Angular NgRx. I'm always happy to help. So thanks very much.
Thank you so much, Sam. Really appreciate it. So we're going to do a little fun next. We're going to do some questions, although I have discovered a little bit of a problem in this. I only have one screen, so looking at my slides with the questions and attempting to show them to you, and also being able to see the comments to see if people respond is a little bit more than I can handle. So Sam and Vincenzo, could you take a look at the comments and see answers come in for me, and I'll read slide questions? Would that be okay?
Yeah, sure.
Okay.
Sorry, I couldn't see any of the comments during the presentation, so I just see that everybody was like, yes, we can hear you. Sorry. Keynote takes over your entire screen. Like, it takes over both of your monitors. You can't see anything.
Yeah.
Stoplight does the same thing. Like I can't even figure out how to see my speaker notes. But let's see. Actually, wait a minute. Hold on. We do have some questions. I am going to try this fancy thing to show you the question. What is the single biggest benefit using RxJS as opposed to plain Redux?
Well, I guess I'm not quite sure I understand. So plain Redux would be in React. So I'm guessing the question is what's the difference, or what's the benefit of RxJS versus NgRx maybe? And I would say that NgRx works really well for large, complex applications, and then RxJS can be used for pretty much anything else. You can still keep track of state through RxJS without using NgRx, which is an implementation of Redux for Angular.
Okay, that sounds good. Then I'll hide it. Anybody else have any questions for Sam before I move on to our trivia questions, our JavaScript Jeopardy as it might be? This works a little bit easier with a live audience. Okay, I'm gonna take that as you're ready for jokes and trivia questions. All right, I am going to present, and then if y'all can look at the comments and tell me when people answer, that would be great. Feel free, my lovely speakers, to answer too. Hold on just a second. Okay. All right, ready to party? Question. No. Okay, well, that one's done. How does NASA organize a party? Anybody?
We got Lance saying they plan it.
Yes, totally right. They plan it. What does Yahoo mean? It's each letter stands for something.
It looks like somebody said find space. I don't know if that's... I couldn't tell if that was for the last one or this one.
Yeah, that was probably for the previous one.
Okay, a minute more, and then I'm going to say you all give up. Okay. It is short for yet another hierarchical officious oracle.
Wow.
Which seems kind of crazy to me. Nonetheless, next one. What sits at the bottom of the sea and twitches? Anyone? Okay, a nervous wreck. Okay, what was the first video game console to have a controller with an integrated mic?
We need the Jeopardy music.
I know. Put that in.
Somebody says phone. Pareto Education says phone.
Phone? Like Phone?
Yeah, I think so.
Nope.
Oh, he means
What?
iPhone.
Oh, iPhone. No. Much earlier, I think. I'd never heard of it before, but to give you a hint. Not that you all have any idea of what I've heard of and what I haven't heard of, but
Was it a Game Boy?
no. All right, I'm gonna Famicom?
Yeah.
I don't know what that is.
It was the like predecessor to the NES, like the Japanese Japanese predecessor to the NES
Okay.
from 1986.
1986. All right. What is the React hook that fires synchronously after all DOM mutations?
You have any bilingual? Was this the Angular meetup or the JavaScript meetup, or I thought it was the Angular meetup, right? Or is it like a broad JavaScript?
It's broad. It's modern.
Yeah.
We call it modern web. It's any modern web topic.
Tracy runs so many events that I get confused about which is which.
It's okay. We have a whole spreadsheet, with lots of tabs to keep track. All right. Well, nobody seems to know what to say.
Pareto you use layout effect.
Yeah.
I was gonna say use effect. I see.
You weren't quite right.
I wasn't quite there.
Next one, the code name for the most recent release of Ember. Okay, what is Octane?
Octane.
Any Ember fans? Why did the PowerPoint presentation cross the road? You gotta have some good dad jokes.
I'm always a fan.
At the start, we take our dad jokes very seriously. We have an entire Slack channel dedicated to it.
Oh, nice.
To get to the other slide. Okay. What is the name of the new compiler in the most recent release of Angular? Somebody had better know that because even I know it.
Oh, we missed Lance's. Yeah, Lance has gotten both now. Ivy.
Yeah.
Ivy.
Yeah, he said to get to the other slide, but I didn't see it.
Oh, okay. Ivy, yep. Why was the cell phone wearing glasses? It lost all its contacts. Okay. The last one. This is the name of Vue's equivalent of React hooks. Okay. What is the composition API?
Oh, I don't know a thing about Vue.
Oh, me neither.
We've been doing this set of events called JavaScript Marathon, and it's really interesting. Like we've been doing events on, each of like Angular and React and Vue and RxJS and web performance and all these different things. And the Vue people are like, they are the most engaged. Like it's really kind of impressive. it's super interesting, kind of what the different communities are like, right? So anyway, all right. Okay, good. That took away my sharing. And then, all right, Vincenzo, it is your turn. When an error is not an exception, take it away.
Yeah. I'm assuming everybody can hear me correctly. I'm going to be sharing my screen. And yeah, and you should be able to see the presentation.
Yeah, I can see it.
Fantastic. So welcome, everybody. I'm very happy to be here with you this night. We're going to be talking about when an error is not an exception. And this is basically kind of an experience that I had while building a project for the company I work for, which is totally open source. We're going to do kind of a case use study and understand why changing a little bit the way we think about the errors can actually lead to probably a little bit of better software. So the agenda, the first thing that I want to tell you is what this talk is not about. First thing first, this is not an introduction to functional programming. I am not at all an expert. I am not entitled to do that. So this is not going to be an introduction to functional programming. It is not a sales pitch to any functional programming library in JavaScript. I couldn't care less. What this topic, what this presentation is really going to be about, well, first of all, small introduction about me, giving you a little bit of the background or my career. Then we'll go over the overview of Prism, which is the project we're going to be analyzing, check a little bit about its requirements and why it is so important, the concept of an error. Then we're going to be exploring what would be the right abstraction to model such particular domain model thing. And then we're going to go a little bit into the political side, like when can you see the return of investment? How do you convince the people in your company in following the journey that you're doing? And see if we can apply a little bit this thing in other context of the of other kind of applications. And then, of course, we're going to have questions later. Before we jump off, just a little warning. If you are one of those functional programming gods coming from the sky and helping us with the thing, you may want to leave right now, because the way I'm going to be introducing some of the concept may probably be bothering you. But I think if we take a more pragmatic approach to the functional programming, it's going to be we need to lower the barriers. And so really the whole goal of this topic is coming into this situation where somebody is going to be like, if you could use Haskell, you can do functional programming and stuff, and you can actually answer, believe me, you can do this stuff in TypeScript too, and check it out, Prism. We have a live project doing that. That is really the idea of the presentation. A couple of words about me. My name is Vincenzo. I am an Italian software developer, but I've been living in Austin for 2 months. I recently relocated, was previously living in Spain and then Czech Republic, bunch of places. I work currently as an engineering team lead for Stoplight. Stoplight is a company building tools for API developers. So from having an idea to getting an API done, that's where we are in the market. So OpenAPI 2, OpenAPI 3, we deal with those formats on daily basis. I am a Google developer expert in web technologies. I've been elected also Auth ambassador for almost 3 years. I am in the API Days committee. It's kind of a franchising, organizing conferences around San Francisco, New York, and even Paris, all these good places around. And I have been elected a Microsoft Most Valuable Professional in developer tooling. In case you want to get in touch with me, email, website, Twitter, GitHub, and if you check out down on the right, you can see my Twitter handle. It's going to be there for the whole time of the presentation. Okay, with that out of the way, let's go to the meat of the talk. What is Prism? Prism is an open source mock server for OpenAPI 2 and 3. I'm not too sure how much you're familiar with OpenAPI 2 and 3. For those of you who are not, those are standard specification that allow you to design your API, your HTTP API, in terms of what paths, what verbs, what will be the responses returned from a particular endpoint, what kind of validation you need to do. And with those documents, you can do a lot of things with it. And what Prism is doing fundamentally is taking your document, as you can see in the image, and it's going to spin up a little server, which is going to behave exactly in the way that has been specified into the OpenAPI document. And so among the main capabilities, we have, hot document reloading, which means if you start Prism with an OpenAPI file and then you change it, Prism is going to notice that and react and reload the whole server. It provides input and output validation. So you can say in the OpenAPI document that the get method for the endpoint path must be an application JSON, must have these fields, those one are required. Prism is going to validate that. And it's also going to validate the responses. And it contains a full-fledged negotiator, which is when a request is coming in, Prism is going to select among all the possible responses for such endpoint, the best one according to the security validation or even the input validation. In terms of the tech, it's completely written in TypeScript. And the main reason is because the whole company has made this huge investment in TypeScript. And so it made sense to just write it in TypeScript. And it is not using any framework. So it's not using Express. It's not using Fastify, nothing of all that. And this is going to be kind of important. The main reason why we're not using any of those frameworks, well, actually, we were using Fastify at the beginning, but then we decided to ditch it out. And the main reason is that I can actually show you here on the screen is that if I go here, the OpenAPI 2 and 3 specification is kind of particular because most of the web frameworks on the market, they cover 80% of the standards. But the idea of Prism was actually to be 100% compatible with the standards. And so there are things that most of the frameworks can handle. Just to give an example, if we go to the way the query parameters can be actually serialized, OpenAPI 2 and 3 specify compatibility with the RFC 6570, but there are also other parts that are not standard, and Prism must handle that because we're aiming for the maximum compatibility with the format. And same goes with the form serialization and even the path parameters. OpenAPI 3 is specifying their own format, so we can use what most of the frameworks are implementing. We needed to roll out most of our infrastructure and code. Okay, so back to the presentation. So that was really the reason why we couldn't really use any of the frameworks there on the market. We had to do everything from scratch. So with that in mind, what happens when a request is coming into Prism? Well, first of all, it goes into a router, which we had to write it from scratch, and then it's going to do path matching, method matching, and server validation. If that's going to be okay, and we're going to find a resource matching those three things, then we're going to be doing input deserialization and validation. And so we're going to be validating the body, we're going to be validating the headers, we're going to be validating the query parameters, and of course, even the path parameters. And all of the stuff, again, have been written by scratch because, again, we're aiming for full compatibility with the OpenAPI specification. And the same goes with the security. If the input is valid, then the negotiator is going to look for the appropriate response based on the data of the validation. And then we also have a proxy, which in case you don't want to use the negotiator and mock the response back, it's going to actually send the request on the origin server. When the response is coming back, either from the negotiator or from the proxy, we're going to be doing output validation and deserialization. And so we're going to be, again, checking out the body, checking on the headers, checking on the media type, content, and eventually we're going to be calling callbacks. But that's a OAS 3 specific thing, and we don't really care about it. So if you see all of those steps, they can all fail, of course. And they're also all failing with a specific code. To give you some example, if the path matching is failing, we need to return 404. If the method is not matching, we need to return 405. If the server validation is not okay, we're going to be returning 404. And for the whole validation, we are actually going to be returning 422 or a 400 or the default response defined into the OpenAPI document. For security, we're going to probably return 401. If we go on the other side, negotiator and proxy, we don't really know what we're going to return here because it depends on the user input, which is the OpenAPI document, or it depends on the response of the origin server. So we can't really say what are the things that we can return. On the other hand, body headers and media pipe output validation, they will return 500. And so when Prism was, kind of being developed and stuff, I was thinking about all these things, and I realized that actually it is very likely you're going to get an error. Everything can go wrong here, and that's even more important because it is even more valid because the input from which the server is being created, it's user input. It's an open API document, which we don't really control. And so last time that I was checking the code, there are 32 paths in Prism, which will lead you eventually to response. 30 of them are actually errors. Only 2 of them will return a successful response. And so if we do the math, 32 over 30, it's 1 on 6, which is probably 0.6% of the requests are likely to be returning a successful response, assuming that all of the possibilities are all even. And so that kind of changed my mind because I kind of say to myself, I really think that Prism's primary job is to return errors. That's the most likely scenario that's going to happen according to the current situation. And this idea, it's even more prominent and valid if we think a little bit about the regular user of the software of Prism. Let's take a look at what I mean here. When you're developing, against an API, making an HTTP call, getting responses, parse the response, and doing something with it, that's usually when you're an application developer. But on the other hand, Prism is for API developers, and the use cases change a bit because the application developer has usually a clear mission in mind. Like he's like, okay, I need to get the list of invoices from my invoicing API, and so I know what I need to do. Most likely, although not 100% of the time, probably they read the documentation, and so they know how to do that, and that's really important. They're likely going to be sending valid data because, again, they have a clear mission in mind, they read the documentation, and so they know how to call the API to sending valid data. And really their idea is they want to succeed. They want the API call to succeed because they need to do something with it. But on the other hand, the API developer, which is dealing with an open API document, which is in the design phase, usually they have an idea what they're doing because, again, we are designing the API. And so the iterations are going to be very, very, very quick. We're still in experimental phase. And probably I'm changing the code or even the specification file every minute. And that changes really the game and the responses. And because of all those things, the generic payload that's going to come, it's likely going to be garbage, invalid, not correct. And so if we sum this thing to the fact that Prism is already kind of returning almost every time errors, this is probably moving the needle of the possibility of all the paths absolutely leaning towards the errors. And so that really validates the idea that Prism's primary job is to return errors. And so I was keeping that in mind, but I wasn't working on Prism at the time. I was working on another project, and Prism was being developed by another team. And so what happened then? I was looking for another project that I was working on, a validation library for TypeScript. Like I wanted to validate some data and get the response and understand if it was valid or not. And if it was valid, having a static type representing my validated entity. I was looking on the Google, of course, and I was only able to find kind of class-based validation libraries or even using decorators, and that was not what I was looking for. And so by looking on Google, I found myself on this tweet, which was really the spark of my thing. Like TypeScript is fine as a language, but it's not leveraging, the ecosystem is not leveraging the types. An interesting example is the IOTS lib. And of course, I was curious. I'm like, wow, I want to check it out. And again, this library really changed my mind about TypeScript completely. Like before, I really thought that the idea of TypeScript is that, you have a function, you put some types on it, and it's going to tell you, if a parameter is a Boolean and you pass it an integer, it's going to tell you, no, you can't do that. You got to give me a Boolean. Or also, if something can be null, you need to prove that it's not if you want to keep going. That was really my idea of TypeScript at the beginning. And that library completely changed my mind. And so I went to the project. I said, wow, OK, I/O decoding and coding seems exactly what I need. I'm going to try this out. So I downloaded the library. I tried to use it. And I was reading the README. And they were like, you define a type, name is a string, surname is a string. Then you decode a payload using the decode method. And then you can see on the right that the methods that were here are like inspect, is left, is right, map, map left, reduce, refiner else, refiner else L. That was giving me a lot of confusion, and I didn't understand what was going on. And so I was on the way to ditch the library, but then completely by chance, I happened to know the author. Completely by chance, I found out that the same guy was hanging out in the same Slack channel. And so I say to him, what kind of cocaine were you taking when you were writing this library? And his response, on the other hand, was, what kind of software have you been writing for all this time? And so we started to chit chat, and I said, okay, I probably misunderstood the intention of the library. Can you help me out with that? And so after a little bit of conversations we had, he said that basically, he introduced me to the functional programming world a little bit. And so what is going on here, it's the idea that the IOTS library is baked by another library, which is implementing functional primitives in TypeScript. And so, again, I just wanted to show one function to give you an idea. But the things are a little bit more complicated, but I think it's important for you to have a little bit of idea of what I meant with that and why that thing fit perfectly. And so if I switch here and I open my Visual Studio Code, you should be able to see my screen. And I'm going to be enlarging this a little bit so you can see probably a little bit better. Yeah, that should do it. OK, so we do have this simple function. And this has been extracted from Prism. But the idea is that you have a function, create param URI template, taking a name, style, and a Boolean. And according to the various things, it's going to return something. Like if this is a simple, if this is a label. And we also have a contingency thing that if there is no thing defined in the enum, we're going to be throwing an exception. And so what if there is another way to represent the error? What if I could do, instead of returning simply the data, I can return an object representing the idea that the computation has been successful. And instead of throwing an error, I can probably return an object that is going to represent the idea that the computation has been failing. And so let's check out the differences. If you remember here, when this thing was just doing regular stuff, the return type was a string. Now that you check it out, you can see that it's telling me it can either return a left with an error or a right with a string. And so this is really the baseline of the whole transformation that happened in Prism. And what are the advantages? So the first thing is that just looking at the function signature, I can clearly tell, okay, this function is telling me that can go wrong. Something can go wrong with this function, and I need to take care of it. And what it's even more interesting is that if I call the function and I pass something, we don't really care about it at this moment, and I try to access the data, I can't. I cannot access the data. The only way I can do that is by handling the error explicitly. And so I need to do something like that. I'm going to do pipe, and then only if the thing is going correctly, and I can actually access my data. This is the string that is being returned. Or I need to handle the error. And so this is going to be my error. This is going to be my error. And so we are having two interesting effects. The first one, there is no way you cannot handle the error, because otherwise you won't be able to access the data. And the second thing, this is informing my software, my domain model, that the error is a possibility. And so for Prism in particular, where errors are everywhere, I thought that it was extremely important to, model this thing as a domain model entity and not as a bunch of thrown exception here and there. So let's go back to the slides. And so in theory, the presentation will be over, but it is not. I think from the technical side, I think it's way more important to see some of the problems that I had during the journey, especially kind of the human side. And so what are the questions that I've been receiving so far while implementing this? Well, the first one, it's probably the most common. Why not using Haskell, F#, Clojure, or whatever fancy language? And for me, this is really not a question, because I know I can write Haskell now, but the idea is that my company has been taking this huge investment in TypeScript, and I cannot come up with other languages and then trying to transpile them. That's just not a possibility. And I think this is really the proof that functional programming is possible in TypeScript. We have a very good set of tooling, and so we just need to be disciplined, and it can happen, absolutely. And so this is not a question for me. The second one that I've been getting, have you ever used this in production, or is just kind of a pet project? And so first of all, yes, like Prism is an open source project. You can check it out, and it is, you can see the source code if you want. That will be a really proof. But also, we, Stoplight as a company, we're offering a hosted version of Prism. And so you can see, we have Prism in our environment, in our cloud environment. And because of the way we've been building the stuff, I have never been able to see a crash. And I've never been able to see an issue on the repository talking about a crash. Because the error is part of my domain model, all the functions, all the software is aware that something can go wrong. And I think this really pays off, especially in cloud environments. Does functional programming always make sense? And my take is kind of most likely yes. Because I've been thinking, maybe Prism was kind of a edge use case. And then I realized it's not. Because if you think about it, if you are looking a user by its username or even its ID, it is a possibility that the network can fail, you won't find the user, or something else is wrong. And why should we model that as an exception, which by definition, exception means something I was not expecting, and so everything is on fire. On the other hand, not finding a user by username, it's something that's going to happen, and you know that ahead of the time. And so why not model your software in a way that it's aware of such problems, so that every single developer needs to handle that somehow? Next question that I've received is that, are you betting everything on an unknown library called IOTS and FBTS? And I'm like, yes. And it's not because the library is fancy, but because it is an implementation of mathematical concept that have theory, and that's not going to change. So maybe there's going to be another implementation called fanfics that I'm aware of, but the mathematical concepts are the same. You cannot cancel them, like the notion of a functor, of a monad, of a monoid, of a semigroup, and all this good stuff. That's always the same. And so the library in this case doesn't really matter, because the underlying concept is the same everywhere. And so I'm happy to do that. Now let's go to the very interesting one. How did I convince the folks in my company? Because you can probably imagine, you're like, guys, we're going to do this thing in a functional way, and not really everybody's going to be okay with that. And so how did I do that? So this is the first pull request that was merged and that was introducing the functional concepts. And you can see that there was somebody not really okay with it. The review was never approved. But then after a while, I was like, you know what? I'm going to be merging this thing anyway, and we'll go from there. I think in certain cases, it's way more important to do something and be wrong instead of not doing anything and be wrong anyway. And so how did I do that? How did I get to that point? The first thing was, of course, voice the problems in the company. I was like, Prism is going to return errors everywhere, and throwing exception is not an option. We need to be aware of the pieces that can go wrong and handle them accordingly and in an appropriate way. returning the correct status code or whatever we need to do. But we need to make sure that every possible thing that can go wrong should be handled. And of course, you need to name the alternatives. I've been thinking maybe we can do something a little bit in C style, returning -1 when something is going wrong, but I will put the error information though, or whatever it is. You need to provide alternatives for the solution you want to implement. And then you need to find a low risk introduction point. You probably cannot see the slide correctly anymore, but the first pull request that was introducing those stuff into Prism was actually the logging of the Prism decisions. And I thought, I think this is probably going to be a low risk point, because in the worst case, logging will not be correct on your console. I mean, yeah, it's bad, but it's not a big deal. Like, the software is going to keep working in the same way. Maybe it's not going to log the things correctly, or maybe we're going to realize that the tooling that I was introducing was not good enough. And so I said, I am willing to take the risk and try it out. Then, of course, you need to elaborate. You need to elaborate your solution in a very verbose way. And I mean it. You can see here how much I had to write to really show the people that what I was doing was really the correct thing. And, making sure that people would understand that I've been putting efforts and I did my homework before applying this decision. This was not a weekend where I was bored and I wanted to try new stuff. This is something that I really felt was a good thing for the project. And then, of course, you gotta risk it. And again, you can see still in the image, nobody was approving the pull request. And then in a certain point, I said, this needs to happen. This needs to happen somehow. And so I'm gonna merge it anyway, and then we go from there. And then, with the passing of the time, the usage of the functional concept and all good stuff has kept growing and growing. And so, we started with the logging, and then I started with the router, and then after a while, we started with other parts. And so what is really interesting here, and that's where you start to get the return of investment, is that when you're writing the things in a functional way, things compose naturally. And so what is happening is that multiple functions, kind of like a magnet, will want to stick together. And if they don't stick together, it means that something is wrong. And I'm going to be showing you an example here. But one of the side effects, it's not a side effect, actually, it's an effect of using these. Some of the functional concept is that we don't really debate anymore on big architecture decision. We already have two rules. If the things compose, you're good. If they don't compose, something is wrong. That's really the only discussion we're having at the moment with regards of Prism. And so how does this kind of a functional thing expand into the software? Like I was mentioning, like when you're writing the things in a functional way, and then with the passing of the time, it acts as a magnet. And so functions want to stick together. What happens if in the middle of two functions that want to stick together, there is something that is not okay? So let's analyze one of the use cases. We were, adding server validation HTTP to the client. And you can see here that I'm going to be reading part of the conversation with you. One of my coworkers was like, this function is starting to look extremely long. It's full of mutation. And if we keep writing it, it's going to be unmanageable. Maybe it is already unmanageable. What can we do about it? And so my coworker was responding, this is a piece of code we don't really want to touch right now because it's too complicated. We have no idea how to do that. It is really too complicated. It's going to take a lot of time. And I also responded, I understand your feeling. I've been struggling to find opportunities to refactor this code. We can't do anything right now. And so what happened is that this part of the code, the validation, was actually in the middle of two functional pieces that naturally wanted to stick together, but there was this validation code that was really bothering us. And you won't probably believe it, but just because of this thing that there were two pieces that wanted to stick together, just separated by a bad piece of code into the middle, well, that kind of naturally solved. Like I was in a Slack channel reasoning about it, and I just started to look at the code and reason about it, and I found myself, well, you'll probably not understand that because that's in Italian, but you're gonna get the point. I was like, oh, I can probably extend the router here with an header, and then I can do this, I can do that. Maybe I should probably remove this thing. And what happened eventually is that I had a plan of attack of how to tackle the function, that piece of code, and I didn't even realize it. It was just about reasoning about the pieces that wanted to stick together and understanding why they could not because of the middle function bothering, and how to make that happen. And that ultimately happened. So, we have been able to refactor the validation completely and remove that bad piece a couple of months ago. And it was kind of a big refactor, but we did it. And just to give you an idea of what I'm talking about, this was the previous situation. And so you can see from the line 39 to probably the line 99, that was the thing. And it is so long that it doesn't even fit on a slide. I need to actually rotate it to make it happen. Now we're in a very better situation. Like it's just from line 17 to line 19, it's probably just 20 lines of code. And of course, I've been splitting this into multiple functions, but the ultimate thing was exactly to make those pieces that wanted to stick together to eventually stick together. And so people have been realizing that this work was going under the hood. Like I was chatting with my coworker, and most of the people in the company were realizing how happy we were with the refactoring, and we were discussing about this thing. Can we use a task header? Can we chain this together? And then what happened is that the day came, like the CEO of the company was like, I will be interested in engineering lunch and learn and understanding FPTS, because from all the talk you did between you and my coworker, I got some interest. And that was a big win for me, at least for me. And then the next question, the secret question that everybody's always asking me, and it is weird though, but there's also always going to be somebody that's going to be like, what about the performances? And for me, this is not a question. Like, it doesn't really make any sense. Well, probably it does, but I really think it's something that I don't even care, because I prefer guarantees rather than speed, at least for the use cases I have. And you can probably argue that Prism is a development time tool, so you can afford to be a little bit slower, but that is eventually not true. Like, we have hosted Prism on the server and it's working great. But in any case, I wanted to get kind of a sense of how much overhead are those abstractions adding to my software. And so I did some of the things, some measurement, and it's, this is just a representation of the flame graph of Prism running on 10,000 requests on a regular document. And if we quickly analyze this, I'm not going to go really into detail because it's going to take too much time. But we can say, you can see at the left, there is a very long column, and that's just a node which is starting up and require the modules and loading them into the memory. So we're not going to take that into consideration. It's something that has nothing to do with functional programming and stuff. It's just a fact of the life that node needs to start the engine and require all the modules and stuff. What I ended up looking here is that less than 1% of the overhead is because of the functional programming concept and things. Like the big problem right now in Prism, I mean, it's not even a problem, but the bottleneck we're having is actually the generation of the JSON examples. So the idea that if you give to the OpenAPI document a JSON schema, we can probably return you a dynamic example. That's really what it's time consuming. And so when I saw that, I said, okay, I'm sold. It's just not an issue. And that kind of concludes kind of my presentation. And the only thought and consideration and observation that I wanted to give to all of you, this is one of the first software I ever developed in my career. I was probably 14. And over the course of my career so far, I realized that I was always doing the same mistakes. And that's why most of the time I was changing jobs, because I was like, this stack is just not okay. Like Visual Basic is not okay. C# is not okay. Java is not okay. I mean, all my problems are because of the stack or of the language. And now with this experience that I had, I think was not the stack. It was really the way I reason about the software that I write. And that leads me to my conclusion is that in general, I think we need to write better software, no matter what the cost is. And so performance or whatever, that really comes later to me. That is really the content of my presentation. I wanted to thank you everybody for listening to me. I'm happy to take any questions. My references are here if you want to get in touch. Thank you.
I don't see any questions in the comments at the moment. Does anybody else have any questions that I'm missing?
Let's see. Okay, I love the name. Hands up if you. Okay, yeah. So now misconception, because Prism is also a code name for another project, which is an highlighter for in CSS. It's also Prisma. It's also an ORM with for GraphQL effectively. But I think we were the first one taking the name, so I think they should be aware, not us. Output validation is ours. Low resolution. All right. It seems like everybody's kind of agreeing with me, which probably is a good thing. But there are no questions. There are no questions so far.
Oh, it works.
It's always nice to be agreed with. All right. Yeah. Well, I think this edition of Bay Area Modern Web is officially over. Thank you both for coming and speaking, and thanks to everybody who has been watching on the live stream. We'll see you next time around. Bye.
Thanks, everyone.